Hello and welcome. I'm Aleksander Tarraro, a software engineer at Noble9. In this talk, I'll try to answer the question, what is an error budget for? This talk is a part of SLO fundamentals path, which is a great introduction to the topic. Firstly, I briefly introduce you to building blocks of something that is called reliability stack. That is SLI, SLO, and error budgets. Once we're done, I'll try to answer the main question. Reliability stack is a set of concepts allowing you to work towards user-perceived reliability. At the base of the stack, there is SLI, your metrics. Level up, there is SLO, your hopefully reasonable expectations towards quality of SLI data. At the top, there is an error budget. It is an information how many errors you're allowed to make before hurting the reliability of your system. As you can see in the diagram, the organization is pretty simple. Let's start with SLI, service level indicators. At its core, it is a stream of metrics describing the condition of your service over time. Services may have many different metrics: DB latency, number of cache misses, average CPU load, and so on. A good SLI, however, measures your service from the perspective of your users. This is a crucial aspect of whole reliability stack because we are about reliability, and you are reliable whenever your user claims so. A simple example of user-centered indicator would be the latency of your website, as it is something every user notices when using a service. We can easily imagine ourselves disappointed with a website being notoriously slow, so that's a measurement that would say something about end user satisfaction. Next is service level objective. Having data from the indicator defined in the previous slide, we can now observe it and define a range of values for which we find single measurement satisfactory. We will tag this incoming value good. If a measurement is outside of the range defined, we will tag this incoming value as bad. Now, observe metrics from the last hour and tag each of the measurements according to the rules defined above. For sake of illustration, let's say there were 3,600 of measurements from which 1,200 was tagged as bad. This means that 66% of the measurements from the last hour was good enough. By defining an SLO, we define target. We define percentage of good enough measurements we expect. As an example, I want 95% of requests to my website finish in 1 second or less. Here we have for web server request, good range defined as up to 1 second and bad range as above 1 second. The objective here is 95%. And the last one, error budgets. Error budget is the amount of measurements tagged as bad you can afford before you violate the threshold of SLO. Mathematically, it's what remains from subtracting SLO's target from 100%. If the SLO is defined as, I want 95% of requests to my website finish in 1 second or less, then the amount of measurement tagged as bad amounts to 5% of all measurements. And that's your error budget. We cannot calculate the actual amount of good and bad measurements if we don't know what our time boundaries are. That's why we use the term time window. It is a period against which we run our calculations. The period can be either calendar aligned or rolling. Calendar aligned time window is the one that have beginning and end fixed to exact calendar dates. For example, from 1st to 31st of May. Rolling time window is the one which boundaries depend on whatever current date is. Time window rolls as the time passes. For example, last 7 days. So, as I said, error budgets is a number of bad measurements you can afford. You can put that into more user-centric perspective. Error budgets is how much patience your users have left. So with all that context, let's go to the question stated in the title of the talk. What is an error budget for? It is for burning. But why not keeping it safe? Well, people easily get used to whatever good happens to them, and that includes the reliability of your service. This means that a non-burn error budget will give your users a false sense of what reliability you promise to deliver. Don't be that RPG player that ends game with inventory full of healing potions for later. Error budgets don't add up, only reset, so your later may never come. Now, let's see what an error budget is good for. I grouped general purposes into two groups, reactive and proactive. Reactive means how you can react to the possibly near exhaustion error budget you already have. Proactive means how you can react to the budget surplus you have. Decision making, reactive one. Imagine it's the middle of the time window, but your error budget is already close to exhaustion. The question is, should you continue to work on features or should you switch to reliability work? It is important to remember that error budget is user patience left. And with that in mind, the safe bet would be to switch to work ensuring reliability. Identifying risk factors, another reactive one. Think of hypothetical situation. It's the middle of the calendar-aligned time window. You have 50% of your budget remaining. By observing how your SLO and error budget has been changing over time, you know that your imperfect release procedure burns down 10% per execution. You are informed that during the rest of the time window, the product team plans to make a release 5 times. Based on the history of error budget expenditure, you know it's a risky thing to do so. You can now suggest either trying squashing those releases into lower count or hold back some of them until the next time window. Another one, alerting. Having an error budget and its pace of exhaustion tracked, we could react to whatever alerting values you claim to be alarming. It's as simple as that, alarming system. Let's now move to proactive, experiments. When having an error budget surplus, we can spend it on experimentations with how changing your application will affect the user's happiness. Try non-feature work you always wanted. Manipulate TTLs, timeouts, number of retries, swapping out libraries. It's up to you to decide. Next is chaos engineering. Similar to experiments, yet separate. Here, you're after disrupting your service and then determine what the weak spot was. This is actively looking for reliability problems before they find you. Chaos engineering includes stress and load tests, black hole exercises, injecting erroneous data to your system, and so on and so on. And the last one I want to mention is shutting down. In case you don't want to do any of the mentioned ways of burning the error budget, you can always just shut down your service for a period corresponding to your error budget surplus. You know, to send the message not to have expectations too high. That's all for this super fast talk. Thanks for listening.